Hello, students, and welcome back. Let me ask you something fascinating. Have you ever wondered why the periodic table always begins with hydrogen and moves all the way forward, yet the first 20 atoms hold such special importance? These first 20 elements, from hydrogen to calcium, are like the foundation stones of chemistry. They include the air you breathe, the salts you eat, the calcium in your bones, and even the helium that fills balloons. By studying them, we understand not only the periodic table's logic but also the chemistry of life around us. So today, let's dive into the world of the first 20 atoms of the modern periodic table. At the heart of the periodic table lies a very simple but powerful idea, the atomic number. The atomic number, written as Z, is the number of protons present in the nucleus of an atom. Because an atom is electrically neutral, the number of protons equals the number of electrons. For example, hydrogen has atomic number 1, which means it has one proton and one electron. The electrons arrange themselves in shells or energy levels following the 2, 8, 8 to rule for the first 20 elements. As you can see on screen, these shells are named K, L, M, and N. This distribution is what gives each element its unique chemical personality. Let's begin with the simplest of atoms, hydrogen and helium. Hydrogen, with atomic number 1, has just one proton and one electron. It is highly reactive and forms compounds like water, H2O, and hydrogen chloride. Helium, on the other hand, with atomic number 2, has two protons and two electrons. Its K shell is completely filled, which makes helium chemically inert. In real life, hydrogen is used as rocket fuel, while helium is used in balloons because it is both light and non-reactive. Look closely at their symbols on screen. Hydrogen is written as 1H superscript 1 and helium as 2He. Two simple atoms, yet so fundamental to the universe. Now let's move to the second period of the periodic table, from lithium with atomic number 3 to neon with atomic number 10. Their electron configurations follow the filling of the L shell, starting from 2, 1 in lithium and going up to 2, 8 in neon. These elements cover an amazing range of properties. Lithium and beryllium are metals, carbon, nitrogen, and oxygen are nonmetals, fluorine is a halogen, and neon is a noble gas. Each has its role in our world. For example, carbon is the backbone of all living molecules, oxygen is essential for respiration, and fluorine strengthens our tooth enamel. Finally, neon, with a configuration of 2,8, is chemically inert and used in glowing signboards. Isn't it incredible how one row of the periodic table contains such diversity? Next comes the third period, stretching from sodium, atomic number 11, to argon, atomic number 18. Here, the M shell is gradually filled. Sodium has the configuration 281, while argon ends with 288, making it a noble gas. In this period, you will find reactive metals like sodium and magnesium, life essential nonmetals like phosphorus, sulfur, and chlorine, and finally argon, which is chemically inert. Think about this. Sodium chloride is the common salt on your dining table, phosphorus is a key ingredient in fertilizers, chlorine is used to disinfect water, and argon fills the bulbs in your home to prevent filament oxidation. Each element is not just a name on the table, it has direct relevance in your life. Finally, we enter the early part of the fourth period with potassium and calcium, atomic numbers 19 and 20. Potassium has the configuration 2881, while calcium has 2882. Both show a clear increase in metallic character compared to their lighter group members. Potassium is an alkali metal, extremely reactive, and essential in maintaining nerve impulses in our bodies. Calcium is an alkaline earth metal, forming compounds like calcium carbonate found in limestone, shells, and even our bones. Fertilizers are rich in potassium and calcium salts because plants, just like humans, need these elements for healthy growth. These two elements open the gateway to the transition metals that follow in the periodic table. So let's quickly bring everything together. The first 20 atoms of the periodic table span across groups: alkaline metals, alkaline earth metals, nonmetals, halogens, and noble gases. Their properties are beautifully explained by their atomic numbers and electronic configurations. From hydrogen in rocket fuel to helium in balloons, from oxygen in the air you breathe to calcium in your bones, these elements are all around you. What the periodic table shows us is the predictive power of chemistry. The structure of an atom determines its properties, and properties explain its uses. I hope now you see why the first 20 atoms are considered the foundation stones of chemistry. In the next session, we'll dive deeper into bonding and see how these atoms interact to form molecules, the real building blocks of matter. Until then, keep looking at the periodic table not just as a chart, but as a map of the universe's chemistry.